Hi, and this is section 8.1, and this section's called Applying Exponent Properties Involving Products. We are starting chapter 6 today, and why don't you real quick, I guess before we get into lesson 8.1, if you just take a look real quickly at page 486, you'll notice that this whole chapter is titled Exponent and Exponential Functions. There's six sections in this chapter. It's not overly long. But actually, there's some pretty neat things at the end of the chapter. We're going to talk a lot about money and how exponential growth and decay, how that applies to money. I think you're going to find some very neat things that you'll see when we get to the second half of the chapter. But we have to understand how exponents and exponential functions work first before we get to that. So right now, we're going to start off on page 489. And I'm just going to have you page through the book with me real quick. There's three key concepts we have to know. The first one is called a product of powers property. I'm going to show you that in a minute. That's on page 49 in the blue box. The second is called power of a power property, and you'll see at the top of page 490. And the third is called power of a product property. Okay, and I think the easiest way to show you those properties is actually to walk through them, using these tables in my video and actually show you what these properties are doing. And it's really important in this chapter, if you don't get these exponent rules down immediately, this chapter will be a big headache to you, and I'm trying to be honest and yet respectful. If you're being lazy, you're not watching the video carefully, you're not actually practicing these things each day, it could cause you a problem where you fall behind, now you misunderstand things, and then I've seen people screw up this chapter royally because they just fell behind, because they did not stay on top of it. The math work isn't very hard in this chapter. The properties you just have to know, okay? If you know the properties, you're going to be in good shape. So let's start off with the first property, and this is called the product of powers property. So they're asking us here in this table to find products of powers. So we're going to learn what this property is. Okay, let's complete the table. First of all, we're going to do, and let me get this out of the way, we're going to do 7 to the 4th times 7 to the 5th power. So let's think about what that means. 7 to the 4th power means 4 factors of 7. And I'm multiplying that by 7 to the 5th power, which means 5 factors of 7. Do you see that when I take 7 to the 4th times 7 to the 5th, what I've really created is 9 factors of 7. I have 9 factors of 7. In other words, I have 7 to the 9th power. All right. Let's go to the next statement here. Negative 4 squared times negative 4 cubed. Well, remember, negative 4 squared means negative 4 times negative 4, and I'm multiplying that with negative 4 cubed, which means negative 4 times negative 4 times negative 4. So I have 2 factors of negative 4 times 3 factors of negative 4. Do you see that I'm multiplying 5 factors of negative 4? 1, 2, 3, 4, 5. Well, 5 factors of negative 4 would be negative 4 to the 5th power. And finally, I'm multiplying x to the 1st times x to the 5th. X to the 1st means 1 factor of x, and I'm multiplying that with 5 factors of x. 1, 2, 3, 4, 5. I have 6 factors of x. 1, 2, 3, 4, 5, 6. And that gives you x to the 6th power. So the first property, what we're trying to figure out is, you know, if I give you, let me say, y to the 5th times y to the 8th, what I'm trying to get you to see here, and I'm sure many of you have already picked it up, you know, what would be the rule for multiplying these two bases? I have 2 of the same base with different powers. I think most of you have figured out to quickly multiply these. What you really do is you just add the exponents. You get y to the 13th power, okay? So to find the products of powers, if you have the same base, if you have the same base, when multiplying, just add the powers. If you have the same base when multiplying, just add the powers. Oop, I should spell multiplying right. Just add the powers. So again, if you look at this table carefully, when I see 7 to the 4th times 7 to the 5th, since I have the same base, I know I can just take 4 plus 5, it's 7 to the 9th. Or here, I have the same base and I'm multiplying. 2 plus 3 is 5. My correct answer is negative 4 to the 5th power. Here, I have the same base, I'm multiplying. 1 plus 5 is 6. I have x to the 6th power. All right? I think as we probably went through that, you were picking up on that. All right? So that's called the product of powers property. Now, you will see that applied in today's homework when you look at questions like number 3 on page 492. Why don't you do that? Do you see how 4 squared times 4 to the 6th would have to produce 4 to the 8th? I have the same base, and all I need to do since I'm multiplying the same base is add the powers together, the exponents. Okay? Just, I should have put, let me write this too. I didn't use very good terminology here. If you have the same base when multiplying, just add, I should say add the exponents. That'd be a better teacher way of speaking that. All right? So there's the products of powers. That's the first concept we have to learn. All right? Let's go to the next rule. The next rule is on the top of page 490. It's called power of a power property. Okay? So in other words, what do you do when you have some base to a power to a power? You see how I have power to power, power to power, power to power. Well, let's see what actually happens. Well, remember, second power means I have 2 factors of 5 cubed. So second power means I have 5 cubed times 5 cubed. Isn't 5 cubed 5 times 5 times 5? And I'm multiplying that with 5 cubed again, which is 5 times 5 times 5. Do you see how I end up with 6 factors of 5? This would be 5 to the 6th power. All right, so 5 cubed squared is 5 to the 6th power. Let's try this one. I have negative 6 squared to the 4th power. So 4th power means I have 4 factors of negative 6 being squared. So let me write that out here. Here's my 4 factors of negative 6 being squared, which really means I have negative 6 squared means I have negative 6 times negative 6. There's 2 factors here. I have 2 more factors here. I have 2 more factors here. And I have 2 more factors here of negative 6. I have 8 factors of negative 6. I really get negative 6 to the 8th power. A cubed cubed. That means I have 3 factors of a cubed. So let's write my 3 factors. A cubed means 3 factors of a times a cubed means 3 more factors of a times a cubed means 3 more factors of a. I have 9 factors of a. I have a to the 9th. You probably already figured out what to do to figure out a power of a power. Okay? So if I had, based on this, it looks to me like if I just multiply these exponents each time, if I have power to power, just multiply the exponents. 3 times 2 is 6, 2 times 4 is 8, 3 times 3 is 9. I'm sure you picked up on that. So when you have power of powers, just multiply the exponents. Okay? Now I should put down, when we have powers of powers, well, I guess I don't even need to say that, okay? Just multiply the exponents, all right? If you have a power to a power, just multiply the exponents, and that will give you the simplified expression. That's what the blue box at the top of page 490 is basically telling you to do, okay? It just says to find a power of power, multiply the exponents, all right? So I would think that's, again, notice the math wasn't hard here. And notice on the previous page, the math wasn't hard here. And yet every year I have people screw these up. And if you're screwing it up, then in my mind as a teacher, it's either not paying attention or lack of practice, because there isn't any hard mental math here. All right? Even if you are not great at mental math, this should be pretty easy to breeze through. Let's draw some conclusions. Let's look at some of these problems. Now, we've only talked about 2 of the 3 properties. We'll talk about the third one in a minute. But let's look at these now and walk through these. And we're just using the 2 properties we've learned up to this point. So in number 1, do you notice how I have the same base? And I'm multiplying 2 things with the same base. All I should have to do is take these powers and add them. That's 5 to the 5th power. That's like what I did on my first slide. Here, bases are the same. All I should have to do is add the power. Remember, if you are multiplying the same bases, just add the I should say exponents. I keep on saying power. Bad grammar on my part. And then here, got the same base. I should have to add the exponents, m to the 10th. Again, no hard math to do there. Here, I have power to power. Remember, just multiply the exponents. This is 10 to the 9th. Power to power, this is negative 2. Oops, my pen froze up for a minute. This is negative 2 to the 12th power. 3 times 4 is 12. And here I'm getting c to the 12th power, just power to power, multiply those exponents. So, if I have the same base, like I do here, and I'm multiplying, I should just add the exponents. If I have the same, I misspoke here, if I have power to power, I meant to say, if I have power to power, I just multiply the exponents. Okay, so let me just go back real quick, because on my video audit I'll do this, okay? So there's 2 properties we've learned. The first property is the product of powers property. Okay, so property number 1 of exponents is the power, our product, I should say, product of powers property. Okay, so that's the first property we've learned. I'll probably ask you what are the properties of exponents that we learned. Product of powers would be the first one. And then we also learned on top of page 490, we have the second property, and I can just write it right here. The second property is the power of powers property. Okay? All right, so then this little sheet went through those, just a little practice over those first 2 properties. Okay, now we have a third property we need to know. I don't have a little worksheet already printed out for that one, but that's okay. This third property is called the power of a product property. Okay, now when you think about what that says, remember product is multiply. Power of a product means something like this. 7xy to the 2nd power. I am taking an exponent to a product. Now remember, this is a product. I'm multiplying these things together. Well, this is what you need to do if you have the power of a product. The 2nd power, the exponent 2, has to apply to each one of these things. I got to take 7 and square it. I got to take x and square it. I got to take y and square it. Now, some people have thought of this and they're like, well, you got to distribute. This is not called distributing, okay? Let me make that clear. This would be distributing. If I had 2 times 7x plus 3y. Distributing is when you have 2 terms. Remember, terms, we're going back to early in the year. You have terms when you're adding or subtracting. I have 2 different terms here. I'm taking 7x plus 3y. I have 2 terms in this problem. Distributing is when you're multiplying a coefficient into terms. There aren't any terms in this problem. It's just, I just have 7xy, so I'm not adding or subtracting anything. I just have to make sure I apply the second power to 7, to x, and to y. Okay, so that's what this property is trying to tell me to do. Just apply the power to each thing or each factor. Okay, each factor. Remember when you multiply, each of these are called factors. So I guess now I'm probably going back to 5th grade math. Okay, I have to apply the second power to each factor. So 7 squared, x squared, y squared. So 7 squared is 49. And I get x squared, and I get y squared. So 7xy squared would be 49x squared y squared. That's the power of a product property. I got to apply that exponent to each factor. Let's just do another one. And by the way, you'll see things like this. Why don't you look at number 27 in the bookwork. Maybe I should just do a couple book problems. 27. You see how I have negative 5x, and it's being squared. According to the power of the product property, I have two factors. I have negative 5 and I have x. I got two factors here. I got to apply the second power to the negative 5, and I got to apply the second power to the x. Well, negative 5 squared is 25, and x squared is x squared. That's 25x squared. Okay? Maybe I should just do one more. If you look at number 30, this is another power of a product property question. It's 5pq to the third power. Okay, do you see how I have three factors in this problem? I have to apply this exponent 3 to each of these factors. So I got to take 5 to the third power, I got to take p to the third power, and I got to take q to the third power. 5 to the third power is 125, and I have p to the third, q to the third. I just applied the power of a product property. So maybe this is another thing in your notes. This is the third property that we need to know. Right here, it's the third property. It's the power of a product property. I'll probably ask you on my video audit, list the 3 properties that I had in the video. Okay, so it'd be good to be able to rattle those off. Let's do just a sample problem here. Look at number 34. 34, they want us to simplify the expression, and it's negative 20x cubed squared times negative 1 times x to the 7th. Okay, so here, first of all, right here, I have to apply the property we just learned, the power of a product. Because do you see how I have a product in here? Really, I have negative 20 times x cubed. So I should apply the second power. I should apply the second power to the negative 20, and I should apply the second power to the x cubed. Okay. Now over here, I'm just going to break this up. The 7th power does not apply to the negative 1. Now, if the 7 was out here, well, then it would apply to negative 1 and x, but it just applies to x right now, so I have negative 1 times x to the 7th. Okay, now, negative 20 squared is 400. X cubed squared, okay? Remember, we're taking a power to a power, and we learned earlier in this video, well, in this case, I just got to do 3 times 2. If it's power to power, that's 6. So I have 400, I have x to the 6th, I have negative 1, and I have x to the 7th. And I want to simplify this. So I'm going to rearrange this. I have 400 times negative 1, and I have x to the 6th times x to the 7th. Well, I know 400 times negative 1 is negative 400. And now here, remember, now here I'm using the first property that we learned in the video. I have two bases that are the same. Remember, if you're multiplying and the bases are the same, don't we just add the exponents? Don't we just add those? So that's where I'm getting negative 400x to the, that didn't show up very good. I'm going to rewrite that 13. It's not very neatly written. That's a little bit better. Okay, so I'm going to end up with negative 400x to the 13th. That's what you're going to be practicing in your book work today. Simplifying these expressions that are all going to have exponents in them, following the 3 rules that you were taught in the video. Okay? There's one more thing I quickly want to go through before I finish this video, and it's on page 491, and it's called order of magnitude, and you'll see that highlighted. And of course, it sounds very complicated, order of magnitude. But it's really a simple concept, okay? Order of magnitude is defined as the power of 10 to the nearest to the quantity, okay? In other words, order of magnitude is used to perform rough estimates or rough calculations, all right? So they give you, I'm looking at the middle of page 491 right now, and I'm looking at that middle paragraph, and read this last sentence of that middle paragraph with me. It says, for example, there's about 91,000 species of insects in the United States. Now remember, order of magnitude, maybe I should write this up here, order of magnitude is just the power of 10, closest, to the given quantity. So if you're looking at that and listening to this and you're like, well, I got to spell quantity, right? If you're looking at this and you're like, what the heck are you talking about? Well, let's go through what power of 10s are. Remember, here are the power of 10s. Power of 10 means base 10 to a power. The power of 10s are like 10 to the first, which is 10, or 10 to the second, which is 100, or 10 to the third, which is 1,000. Remember, 10 to the fourth, again, this should be a review of some 7th grade material, 10,000. 10 to the fifth is 100,000. Oop, let me write that right. 10 to the sixth would be 1,000,000, and so on. These are the powers of 10. So when they want the order of magnitude, like for this example here, there's 91,000 insects in the United States. The order of magnitude for the number of insects in the United States would be which of these numbers is closest to that? Well, the order of magnitude of the insects in the United States would be 10 to the fifth, because 10 to the fifth is the closest base 10 to 91,000. That's all order of magnitude means. So when you look at example 5, look at example 5 right now on page 491 at the bottom. They have a problem involving this with order of magnitude. It says for bees, in 2003, the U.S. Department of Agriculture collected data on about 10 to the third honeybees, so about 1,000. So there's 10 to the third honeybees. Okay? Colonies, 10 to the third honeybee colonies. Maybe I should write that down. Okay? Now remember, a colony would be like a nest of bees, right? We have a colony of bees, that'd be a whole nest. That's not individual bees. That means there was 1,000 different bee colonies in the United States. There are about 10 to the fourth bees in an average colony. Okay, so there's 1,000 colonies and every one of them has 10 to the fourth bees. So if the numbers are too big to wrap your mind around, think about it this way. Pretend we had 2 colonies, and a colony means a nest, and each nest had 10 bees. So you have 2 colonies, 10 bees. If I asked you how many bees do you have, I think you'd figure out right away, well, wait a minute, it's 2 colonies, 10 bees a colony. You would just do 2 times 10 is 20. Well, we're doing the same thing here. The numbers are just a lot bigger, okay? I have 10 to the third colonies, and every colony has 10 to the fourth bees. Well, we're going to use exactly what we practiced in one of our rules, okay? We're going to use rule number 1 right now, product of a power. You notice how the bases are the same. If the bases are the same and you're multiplying, don't we just add the exponents together? The correct answer to this would be we have 10 to the 7th bees, okay? So that's what order of magnitude is for. It helps us do rough estimates on very large numbers. You'll have a few order of magnitude questions in your story problems. That's all order of magnitude means. Another one would be number 46. It talks about population, order of magnitude. Okay? Another good thing for me to ask about in my video audit tomorrow. All right? I think that's going to stop my video there. This has been plenty long, but we had a lot to cover. We can go over any questions you have tomorrow.